Hello everyone, my name is Untitled and I'm a developer of digital platform for system validation at Renault. Today I will present you one of our platform which is made by RT Lab as the heart of the system. The goal for Renault is to have a unique process of validation with same test case from a textual specification to the real car. With the simulation platform that I will present today, we can use it on different environments. One of them is a workstation for development and manual test. Another one is the cloud for massive simulation and massive use case validation. And the last one is the real simulator to have the driver in the loop and check customer performance. All of these environments use the same inputs like ECU's model, environment models, or the electrical and electronical architectures of the car. As I said, RT Lab Orchestra is the heart of our simulation platform. We connect to Orchestra all our ECU models, which is made by Simulink or C++, compiled as executable, and for Simulink compiled as executable by RT Lab. We connect also to Orchestra a simulation of the network, like CAN, LIN, or Ethernet. We connect also 3D simulation to simulate the sensor and the 3D environment around the car. We connect also a guide tools to control actuator like pedal, steering wheel, or something else, or test sheets. But we don't use these tools on this project that I will show you today. So on our project we have three tools: RT Lab, which is the heart of the platform, and where we create the framework, the data exchanger of all our domain of Orchestra, like CANU, Simulink models, executable models, and scanner. And now I will show you the path of three kinds of signals inside our platform. So on our car, we use a CAN network to exchange data between ECUs, and in our platform we simulate this network by CANU. So our ECU model, which is in RT Lab, sends its signals to CANU through Orchestra, exchange the data inside the CAN network or Ethernet network or LIN network to receive to another ECU. CANU send it to Orchestra, and Orchestra send it to the other ECU. So the path is something like this. We have also analogic signal that we call wired. So this kind of signal is exchanged directly from one model to another one, also through Orchestra. And the last one is the sensor data, which is generated by scanner and sent directly to model ECU with UDP. Soon we will use, of course, Orchestra to exchange this data. Now I will show you the launching process of a simulation. So we write scenario inside scanner, where we define what kind of ground, what kind of traffic are around our car, for example, and define the sensor, where we can put a camera sensor, radar sensor, LiDAR, ultrasonic. In scanner, our car is simulated by model handler, and behind model handler we have our vehicle, simulate with our ECU models inside RTLab or as executable, connect to Orchestra, like I said earlier, and the simulation of the network. We have a last one tools, which is Scanner Compute, to launch a package of scenario, and we start at each new scenario the vehicle. Now I will show you how we are using RTLab in Renault. So RTLab is using to simulate all our Simulink models and to exchange all the data between all the Simulink and the other software. So we create a framework, which is the master of Orchestra. This Simulink model is generated automatically by Renault tools, and it depends on the number of the domain inside Orchestra, so the number of ECU models and the number of input-output on each of these models. The framework realizes the mapping between all the domains. So inside Orchestra, for this example, we have 12 Simulink, 2 black box models as executable. So here you can find the Simulink models inside RTLab and the same name inside Orchestra. So here we saw the DDF, which is the definition of Orchestra. So we have 2 black box executable, which is BCM. We don't find it here. Canu, which is the Canu software for the network simulation, and here the ECM, another black box. On this project, we exchange more than 20,000 signals. We have more than 12,000 doubles, 3,000 int, and 4,000 bytes. Some of them are vectors, and the fastest step time on all our models are 1 millisecond. So the framework here run at the step time of the fastest models, which is 1 millisecond. So the frameworks run at 1 millisecond. So we exchange 20,000 signals at 1 millisecond. We also use the data logging of RTLab to record some information from our models, and we use also the trigger function, and we put the trigger function on signals which say that the vehicle is start. Now I will present you Canu. So we create a Canu configuration which represents the network of the car with the message set of the car. So it's a database which we group all the exchange between ECUs. In this project we simulate 11 CAN networks. Soon we will add 2 Ethernets, and sometime we simulate 3 LIN. It depends on the project, but on this one we have 11 CAN. Vector, the editor of Canu, integrates Orchestra for us. So here we have a specific node which receive and send information to Orchestra. So receive information from Simulink models or executable model and send it to the network. And this configuration is generated by Renault tools. So here is Scanner. So inside Scanner we can configure our 3D environment. So we can set a ground, the type of road, the number of vehicle on our scenario, so the traffic around our car, our testing car. We can create scripts to check if we have a collision or not, for example, and stop the simulation. I will show you this kind of scenario, which is an AEB for emergency braking. So we can also configure the set of sensors of our car. So on this scenario, we can use radar and camera, but we can also use ultrasonic and LiDAR. Here is the configuration of the sensor. Our vehicle with ECU in RTLab and network in Canoe is behind Model Handler, and the software RTLab and Canoe is launched by Digital EE Batch. All the use cases, the scenario, are generated with one tools automatically. Now I will show you how the platform is launched, how the simulation is launched, and how with Scanner and its scenario we can start RTLab thanks to the API of RTLab and Canoe behind Scanner. So here we load our scenario and start it. So now we are waiting two modules, Model Handler and Digital EE Batch. So behind Model Handler it's our vehicle, so we are waiting for RTLab and Canoe, and behind Digital EE Batch it's the tools that we now create and use RTLab API and Canoe API to launch the configuration of RTLab and Canoe. So now we can see that all the models inside RTLab are launching. I will accelerate. We have also our executable, or black box, which are launched by Digital EE Batch. And now we start manually for this presentation, but it can be started automatically by Digital EE Batch Canoe. In Canoe we can see all the frame exchange between ECU, so it's scan frame. We can see the signal inside graphic if we want, and on Scanner we can see the car moving. We can also check some data during the simulation inside RTLab, so inside the model. All the processes are running, so the simulation is started. At the end of the simulation, we can see all the processes inside RTLab in visiting mode. And now the simulation is finished. We use also the functionality of co-simulation of Orchestra in our platform to develop and debug some models inside Simulink. We can do it with black box model, of course. So to do that, we remove one or several models inside the RTLab configuration. So this model will be not launched by a Digital EE Batch from the scenario, and we will launch them inside Simulink directly. So here we start the scenario. So we will see here all the models running. I remove the AEB, we'll configure the model to run in Simulink mode. So now with this mode, the Simulink will connect to Orchestra, so the framework, the master of Orchestra, and we will be able to see all the data that we want inside the model. So now we are waiting that all the models are started, CANU and everything else. So now the simulation is launched and we can check the data. So here we check if the sensor detects a target in the front of our car to do emergency braking. So at the beginning we are very far from the car, the target, the other car, the other target. So we are waiting to be near it. And we are waiting to see something from the sensor to stop the simulation in Simulink. And due to the synchronization of Orchestra, every domain, every Simulink, every software, so scanner, CANU, every Simulink model, every executable black box will be stopped. And we can analyze all the data inside our Simulink. And can run step by step the simulation if we want. I'll show you only one Simulink model in co-simulation, but we can run 1, 2, 3, 4 Simulink model at the same time with co-simulation with Orchestra co-simulation. So in the previous slide I show you how we launch a simulation of platform on the workstation to develop, debug the platform. But the main goal is to run this simulation on the cloud for massive validation. So to be able to run our platform on the cloud, we must create a vehicle package that will be imported in the cloud for run our scenario with scanner. So create a package of the vehicle which is behind the model handler inside scanner. So first of all, we will add the AEB that we remove for co-simulation inside the RTLab configuration. Then we will export the CANU configuration to be able to run it on the specific tools for the cloud, so that it can be exported for Windows or Linux. Inside RTLab, we will compile all the model in Windows or Linux. It depends on the OS that we will use on the cloud. So for example, we are on Windows. And thanks to a function inside the RTLab API, we can use a Python script to export our RTLab configuration. Okay, so now we are in scanner, and in scanner we will use the package that we create to export it to the cloud. So here we have a zip of our vehicle with RTLab project, our black box model, ECM and BCM, and the canoe configuration, the .rtcfg. Now that we created our vehicle package which contain ECU models inside RTLab configuration and our network simulation with our canoe configuration, we can go inside the web interface developed by Weno to create and launch a validation campaign on the cloud. So here I show you a screenshot of the first page of our web interface. So here we can create a simulation plan that contains a platform. So here we can create our platform, it's our vehicle. So we can put the package that we created with RTLab and Canoe, and also import the set of sensor of the vehicle. So it's for the scanner configuration. Then we create a package of scenario. So a package of use case, ground, traffic, depending of the use case to test. And then we create the simulation plan where we choose a vehicle and a package of scenario. After that we launch it and it's running on the cloud on several instances to be as fast as possible, and we can drive literally several million of kilometers in short time. When our plan is finished, we can now analyze the results of each scenario. So on the web interface we have a tool to analyze all the scenarios automatically. So it's realized on a special cloud server. And for each scenario we can choose, when we create the plan, some warning and indicator, like if we meet a collision or no, if the function are activated or not. And at the end of the plan we can see very quickly if we have too much error or not for this validation plan. The most important things to know about the result is the reproducibility. So if we run the same scenario at the same time, we must have the same result. So now I will show you what kind of result we can have. So here I will show you two results of the same scenario. So for each scenario we have one group of log which contain scanner log, canoe log, and of course RTLab log. So RTLab log are .mat, it's in MATLAB format. For canoe it's a BLF, and all the other file is for scanner. The possibility in scanner is to replay the scenario with the record and check in 3D the status of the simulation. So here I open one record and I can replay it. So at the end of the simulation here we can see the collision or not. So here the function successfully succeed. And now I will open a new scenario, a new record, which is the same scenario, to see if we have a reproducibility. So with graphic, I will check the vehicle speed. We can see only one curve, so it means that the results are the same with the same scenario. So everything is okay. Today, I presented to you a virtual platform which will be used to validate the AEB system in an environment representing the car's electronical and electrical architectures, as well as the ECUs around this function. We simulate ECUs designed by Renault or its suppliers. We also simulate CAN, LIN, Ethernet networks, and the 3D environment. We can also validate other ADAS functions, such as LKA, lane keeping assist, or autonomous driving function. Thank you for listening to me. If you have any questions, we will now try to answer them.